Let's solve this problem live. I have solved this sometimes ago. So let's practice and let's solve this. Given integer nums and an integer target. Return indices. Return indices. So we have to store the indices of the two numbers such that they add up to target. Given two numbers add up to target, represent the indices. You may assume that each input would have exactly one solution and you may not use the same element twice. Okay, you may assume that each input would have exactly one solution. Okay, okay. You may not use the same element twice. So we have written two different indices that's what it's saying. You can return the answer in any order. Fine. Example 2, 7, 11, 15 target is 9. We have to return 0 and 1. Okay. So the best way to solve this will be using a hash map. Why a hash map? Because suppose we are traveling through the array, we for let's say for 7, we will see if 2 is there. How we will get to 9 minus 2 means target minus the current value. If that is in the array, then we can return the answer. So the reason behind using hash map is if you use array, that will be we are searching for 2. Searching an element in the array is checking the whole array means an ON operation, but in a hash map, because of hashing, it's O1 approach. Searching is O1, inserting is O1, deleting is O1. Hashing is always a huge advantage. So we will, uh, what I can name this as scene. What scene is convention means what we have seen so far. Let's put for. Since we need the indices, we have to need I. In Python, there is a function called enumerate. I comma x in enumerate. Now, enumerate is that you can in range in, then do that as well. But it looks good for I in x. The enumerate in x is the value I then comma x in enumerate comes if look search if x in c has seen x input. Let's say no, sorry. We need the complement. Complement is target minus the current value. We need the complement. Now I see is complement in the scene. Have you seen the complement? Is there a complement? Exist. Till now. If complement not any scene. What does the in operation? It's search basically. If complement in scene, then we got the but I will return before that. We have to how scene will work. For I comment in magnum, you can insert the x in the scene. How the scene x is equal to I. When I do that, the key will be the actual value and the value will be the indices. And I assume that each input would have exactly one solution. We can do that. We can do that. There are not duplicates. No, there are duplicates. We can do that because these are too unique, right? So there is the problem. Let's see. Phoenix is equal to means here inside the equation space. So if complement is seen with something there as it's already seen, return an array. Obviously the current time and the scene of complement. When complement in the room, I will make the index of the complement. So we can return this. Any other thing, say that will exist. So it will already return thing. Already exist. Let's see what have we done wrong. We haven't done anything wrong. Got accepted. So let's try that now. What happened for this? Let's see. X is 2, I is 0. Its complement is 7. Have we seen the complement 7? No, I haven't. So doesn't run this. Phoenix means get populated by the key 2 with the value 0 to 0. Mhm. Then we go to 7, calculate the complement, that is 9 minus 7, it is 2. Have we seen 2? Yes, we have. Where is 2? The value of 2 is 1, is 0. So it returns 0, it returns 1. So this is 0, 1, it's any order, so it got accepted. So that's the solution. Easy one, easy peasy.